Get ready to witness the impossible. China is changing the construction landscape, pushing boundaries with mega projects that leave engineers worldwide in awe. Think colossal dams that generate record-breaking amounts of electricity, tunnels built through impossibly tricky terrain, and bridges that make you feel like you're walking on air. These projects aren't just big, they're fast. China is known for constructing massive highways, sprawling bridges, and sleek high-speed rail lines at mind-blowing speeds. Advanced technology, cutting-edge construction methods, and an unwavering determination fuel this relentless pace. Some might even be shocked by this rapid progress, this ambition that turns blueprints into reality with astonishing efficiency. But how does China do it? What secrets lie behind these engineering marvels? Let's dive in and discover the ingenuity that shapes some of China's most insane megaprojects. The first project on our list, and it's a doozy. Imagine a city's busiest highway artery, choked with traffic day and night. Now, imagine the bridge at the heart of this network suddenly becomes dangerous. Traffic can't stop, not for months. It's a logistical nightmare, unless you're a Chinese engineer, apparently. Behold the Sanyuan Bridge Replacement Project. Flashback to Beijing 2015. The Sanyuan Bridge is old, and the traffic load is unbearable. It's literally sagging under the weight. This bridge carries over 200,000 vehicles a day. Replacing it the traditional way would cripple the city for months. Nope, not an option. So here's the plan the Chinese came up with. Picture this: midnight, November 13th. They completely shut down the bridge. What follows is a symphony of cranes, precision technology, and raw power. The old bridge has to come down, and fast. First order of business: cut that thing to pieces. Saws slice through concrete and steel, breaking the old bridge into 27 giant chunks. The heaviest weighs about 139 tons. That's nearly twice the weight of a blue whale. Now, the tricky part. This demolition takes place while the old bridge is still partially standing. If we mess this up, the whole thing could collapse. Each of these gigantic chunks has to be lifted off by massive cranes, careful not to disturb the rest of the teetering structure. Talk about high-stakes Jenga. But here's where it gets truly wild. While this demolition ballet is happening, the new bridge is nearby. It's massive, nearly 1,300 tons, fully assembled. How do you move something so big so quickly? Enter the Shentuo, two monstrous Chinese-made transporters. These behemoths have 96 wheels each and can lift insane amounts of weight. See, these machines are linked and synchronized perfectly. They grab the new bridge and start moving it like it's a toy. But here's the kicker. This bridge has to be positioned perfectly onto the old supports. The margin of error? Millimeters. They use GPS, lasers, and the whole 9 yards. It's an engineering marvel in real time. Slowly, with agonizing precision, the new bridge slots into place. And get this, from start to finish, the entire process takes 43 hours. Less than 2 days. Beijing's traffic nightmare is averted. This project is a masterclass in speed, innovation, and the sheer audacity of Chinese engineering. It makes you wonder what other mind-blowing projects are just waiting to be unveiled. Stay tuned to find out. Now, buckle up, because if a bridge rebuild in 43 hours impressed you, China's high-speed rail network boasts an even more mind-bending feat, constructing a functional train station in a mere 9 hours. Let's dissect this engineering marvel and see how they pulled it off. First, some context. This wasn't a brand new station sprouting from scratch. The project involved upgrading a crucial section of track near the existing Longyan Station, a bustling hub in Fujian Province. The goal? To seamlessly integrate the station with a brand new high-speed rail line. Imagine the impact. Journeys that once took 7 hours would be slashed to a breezy 90 minutes thanks to these sleek bullet trains zooming at 200 kilometers per hour. Now, here's where the 9-hour magic happens. The key lies in meticulous planning and a heavy dose of prefabrication. Months before the big night, engineers meticulously mapped out every step of the process. Think of it like a high-stakes chess game, where every move needs to be calculated in advance. Prefabrication became their secret weapon. Instead of painstakingly laying the track on site, pre-assembled sections, complete with sleepers and ballast, were cast off-site in dedicated facilities. Imagine giant Lego pieces for a high-speed railway. The big night arrives, and 1,500 workers descend upon the site with military precision. Time is of the essence. Disrupting a major station like Longyan for an extended period would cripple the city's transportation network. So they work through the night, a well-oiled machine divided into specialized teams. One group focuses on dismantling the existing track, another on meticulously removing the old interlocking system, the complex network of switches that allow trains to maneuver between tracks. Here's where things get fascinating. Remember those prefabricated track sections? They come into play now. Specialized cranes and rail-mounted machinery, pre-positioned for maximum efficiency, swing into action. The pre-built sections are carefully lifted and slotted into place with laser-guided precision. It's like watching a construction ballet, every movement synchronized to avoid any delays. Meanwhile, another crucial task unfolds. Skilled electricians meticulously rewire the entire section, ensuring seamless integration with the existing signaling system. These guys are the unsung heroes, making sure trains can navigate the new track safely. As the prefabricated sections are laid, other teams tackle the ballast, the layer of crushed rock that provides stability to the tracks. They use specialized machinery to spread and compact this crucial layer, ensuring a smooth ride for future high-speed trains. With clockwork precision, the teams work through the night. The old interlocking system is replaced, the prefabricated track sections are secured, the ballast is compacted, and the electrical connections are complete. As dawn breaks, they take a collective sigh of relief. The impossible has been achieved. A fully functional section of track, ready to handle the high-speed behemoths, has been built in a mere 9 hours. If you thought a 9-hour train station was impressive, buckle up. China took on a maritime challenge of epic proportions, designing and constructing the world's longest sea crossing, the Hong Kong-Zhuhai-Macau Bridge. This behemoth, stretching a mind-boggling 55 kilometers across the Pearl River estuary, isn't just about convenience. It's a linchpin in China's ambitious plan to transform the Greater Bay Area, a network of 11 cities, into an economic powerhouse. Here's where engineering ingenuity meets ambition. This wasn't a simple bridge build. Picture the challenges: frenetic shipping traffic, the wrath of typhoons, and delicate marine ecosystems, particularly those of the iconic Chinese white dolphins. The solution? A complex feat combining bridges, tunnels, and artificial islands. Let's focus on the main bridge, a 29.6-kilometer marvel in itself. To minimize disruption and preserve those dolphin habitats, engineers opted for slender, single-column piers anchored deep into the seabed. Above the waves, 3 cable-stayed bridges, each with unique, sail-like towers, rise to support the massive carriageways. It's an aesthetic statement as much as an engineering achievement. Now, about those artificial islands. These aren't just mounds of sand dumped into the sea. They've meticulously engineered structures crucial to the bridge's functionality. They seamlessly transition traffic from colossal bridges to a 6-kilometer-long underwater tunnel. Think of them as giant traffic interchanges in the middle of the ocean. Speaking of underwater tunnels, this project features one of the most complex ever built. Instead of boring through solid ground, it's made of 33 massive concrete sections, each weighing a staggering 80,000 tons. These sections were carefully lowered into place, forming a massive underwater highway. It's a testament to the precision and power of Chinese marine engineering. And let's not forget the logistics behind this mega project. Coordinating massive construction teams, specialized machinery, and the movement of building materials across land and sea over a 9-year construction period is a ballet of planning and problem solving. The result? A journey that used to take hours by ferry now takes a mere 40 minutes by car. The ripple effects are huge: increased trade, a boost to the tourism industry, and the symbolic binding of major cities into a future regional powerhouse. The Baihatan Hydropower Station, a testament to China's clean energy ambitions, stands as another megaproject that reshapes our understanding of renewable power. This beast of a power plant boasts an installed capacity of 16,000 megawatts, capable of generating over 62 billion kilowatt hours of electricity annually. But the real story lies in the engineering feats behind its construction. Let's start with the heart, the turbines. Baihatan breaks records by sporting 16 gargantuan 1,000 megawatt hydroelectric turbines, the largest ever built. Forget numerous smaller turbines. This approach means lower installation costs, reduced maintenance, and a jaw-dropping energy conversion efficiency of 96.97%. But how did they pull off designing and building such behemoths? Deep within each turbine, a complex water guide mechanism dictates the incoming flow of water. It's a critical component for stability and efficiency. SKF's sealing technology plays a pivotal role here. By minimizing water leakage around moving parts, they've slashed theoretical leakage levels to a mere tenth of what's typical for such massive turbines. This ingenuity directly translates to greater power output. Now, let's venture outside the turbines. The force these machines generate is held back by a colossal 289-meter concrete arch dam, the height of a 100-story skyscraper. This isn't just about keeping a lake in place. This structure withstands an unimaginable hydraulic force of 16.5 million tons. It's meticulously engineered to function safely under extreme floods and earthquakes. To control water flow under emergency conditions, a massive quick energy gate relies on the world's biggest hydraulic hoist. This beastly cylinder, with its ceramic-coated piston, can lift the equivalent of 800 cars. Inside, SKF's specialized spherical bearings ensure smooth operation and exceptional load-bearing capacity despite the harsh, humid environment. But it's not just brute force, it's about precision. SKF's sealing technology keeps this hoist functioning flawlessly, preventing hydraulic fluid leaks and protecting internal components. Specialized materials with anti-friction and anti-creep properties are vital for long-term reliability under the relentless pressures of this environment. The Baihatan Hydropower Station isn't just a source of clean energy, it's a marvel of modern engineering. From the awe-inspiring scale of the Baihatan Hydropower Station, let's shift gears entirely and focus on the lightning-fast construction of